Today we're going to talk about proving triangles congruent using CPCTC. And if you look down here at the bottom, before we even look at the rest of it, the last sentence in this paragraph says, this stands for congruent parts of congruent triangles are congruent. So what we're going to do today, it says with triangle proofs, sometimes we need to prove that parts of the triangle are congruent. When this happens, we first need to prove that the two triangles are congruent. So that's when we use our side angle side, or our angle angle side, or our side side side, whatever the other one is. I can't think of it right now. And then we prove that the parts are congruent. And when proving parts are congruent, the reason will always be corresponding parts of congruent triangles are congruent. So let's see how this works in our first proof here. And as we look at this first proof, what I hope notice immediately is that this is a shared side triangle. And we can start by writing down our given, which is that CB is parallel to DA, and CB is congruent to DA, and that's our given. And eventually, what we want to prove is that angle C is congruent to angle A. So let's look up here and see if we can come up with a couple of reasons that we might be able to fill in so that we can complete this proof. In one of the first statements, it says CB is parallel to DA. When we have something parallel, oftentimes what we have is we have alternate interior angles are congruent. And something else that we might notice here is we've got shared side triangles, and we have shared side triangles. Somewhere in there, we're going to be using the reflexive, if I can spell it right, reflexive property. In fact, let's take a look at our picture now and find where we're going to be using the reflexive property. And if you notice, this length right here is a part of both triangles. It is the shared side. So we can say that BD is congruent to BD, again, because of the reflexive property. We also have parallel lines in this picture. Here's a parallel line, and here's a parallel line. And what we're going to be looking at is we're going to be looking somewhere for our alternate interior angles. So two parallel lines cut by a transversal, and what happens is that alternate interior angles are congruent. And now that we have that marked up as well, we can make our statement here, which is that angle CBD is congruent to angle ADB. And again, those are the two parallel lines cut by the transversal. The alternate interior angles are congruent. Now, I didn't mark up our reflexive property, so as I look at statement 3 again, what we said that BD is congruent to BD. And when we take a look at this, now we can state that the triangles are congruent. And let me just highlight what triangles we're working with here. Here is one in red. And then we'll put this in pinkish purple here. Here is the other one in pinkish purple. So now we take a look at that, and what we can say is we can say that triangle CBD is congruent to triangle, well, let's see, CB had the two tick marks on it, so ADB And the reason is, if you look at that, we've got a side with 2 tick marks, then we've got an included angle, and then we've got the green 1 tick mark, and that's from the red triangle. But then in the pinkish purple, we've got a side with 2 tick marks, and then we've got the angle, and then we've got the green tick mark, the shared side. So what we can say is that these are congruent, the 2 triangles are congruent by side, angle, side. And then angle C and angle A are each a part of either the red triangle or the pinkish purple triangle. And because they are a part, and we've already proved that the triangles are congruent, we can say that these 2 values are congruent as well, because it's a corresponding part of congruent triangles are congruent. If you notice, we've been talking about shared side triangles, and now we're talking about a bow tie triangle on this next one. And what we've got is we've got I is the midpoint of AO, and angle X is congruent to angle M. So we'll start there with filling in our given. I is the midpoint of AO, and angle X is congruent to angle M. And that's our given here. And before we get too far, why don't we mark at least the fact that angle X is congruent to angle M. And let's fill in what we're trying to prove, which is going to go here in statement 5, and that's going to be our AX is congruent to OM. And now let's see if there's anything that we can fill in terms of reasons. And if we go back to our given, we see a vocab word. We see midpoint. It's kind of jumbled together. Midpoint of. I did have to abbreviate to fit it all in there. But one of our reasons is going to be definition of midpoint. And within bow tie triangles, we always seem to have, and we do, vertical angles. So vertical angles are congruent. And in fact, let's fill in those vertical angles. Let's mark them in our triangle first of all, which is here and here, those 2 angles. And we can say in terms of our vertical angle, let's say angle X, I, A is congruent to angle M, I, O, again because of the vertical angle. So I started with the 1 tick mark, then I went to the 2 tick marks, and then I went to the angle without the tick marks. It might have been better if we filled in definition of midpoint, the statement with the definition of midpoint first. But it says I is the midpoint of AO. Well, what that means for us then is that this length is going to be the same as this length, because I is in the middle of the segment AO. So what we can say in this particular case is that AI is congruent to OI. And again, that's our definition of midpoint. And we actually have enough now to prove that these 2 triangles are congruent. And what we can say is that we can say that angle XIA, or sorry, triangle XIA is congruent to triangle MIO. Because what we have in this particular case is we have two angles and not an included side. And when the side is not included, we can say angle side is the reason. And then in each of those two triangles, we've got length AX in one of them, we've got OM in the other. They are a part of each of the triangles that we just proved congruent. And with parts that we prove congruent, we can use CPCTC. Flipping our paper over, we have the isosceles triangle theorem. And it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. We actually have used this before earlier in the school year. But just to point out what it was is we said that if AB is congruent to CB, so this length is congruent to this length, then what we could also say is that angle A is congruent to angle C. And I'm not quite sure what Miss Collini did, but I extended that line. I said, okay, well this is congruent to that. So that may or may not work for you, but it'll get you going at least in the right direction. Angles opposite congruent sides are congruent is really what this statement is saying. So if we look at our last proof today, the nice part is that we do have our possible statements and possible reasons, but we don't even need some of it to fill in here. We'll start with our given, and our given is that PL is congruent to YL, and LA bisects angle PLY. And that's given. We also know that we want to prove angle P is congruent to angle Y. And I want to be a little bit more careful here while making the video to watch my statements and reasons. So let's go down and see if we can mark anything off. Given, we can mark that one off. Angle P is congruent to angle Y. We can mark that one off. And then we've also got this, I believe, was our given statement. So we can get rid of a couple of things. But one of the things that I notice here is that there's a vocab word in our given. And when I see a vocab word, I'm going to look down here, and bisects is the vocab word, and our possible reason is definition of an angle bisector. So let's fill that in, even though we don't know the statement yet. So we can use definition of angle bisector. Cross that one off. Another piece that I notice of this particular picture seems to be pretty common is that we have shared side triangles, and when we have shared side triangles, then somewhere in this problem we're going to need reflexive property. So we'll look down here in our possible reasons, and hopefully we've got that, and we do. So we can get rid of that one. And remember that really what we have to do is we have to prove that the triangles are congruent, and once we prove that the triangles are congruent, then we can say that the parts of the triangles that we haven't specifically talked about are also congruent because of CPCTC. Luckily enough, we have the PL and the YL already marked for us. Let's stick with the reflexive property that we just filled in, and what we see is that our same side is this side right here. Again, I'm going to erase that, but at least you saw it. So we can use that by looking over here at our statements and we have LA is congruent to LA. And not only will we cross off that, but let's mark it here in our picture. If we go back and look at definition of angle bisector, it says that LA bisects PLY, and ultimately what that means is that this angle, sorry, I'll try one more time. This angle is congruent to this angle. And the reason that those are congruent is because of definition of angle bisector. So we can say that angle PLA, let me look down below just to make sure that I'm saying it the right way. PLA is congruent to angle YLA, which is at the very bottom left of our possible statements. Angle PLA is congruent to angle YLA. And now that we've got that in, we can cross off that option. And then hopefully we have enough information to say something about our triangles. And luckily in our possible statements, we only have two choices of triangles. But as I look back up here, what I see here is that it looks like angle PLA is congruent to angle YLA, but I don't think that's what our statement says down here. But let's see, if we do PAL congruent to YAL, that's going to work for us. So I went in the wrong order originally, but I'm going to follow what the possible statements are, because again, when we take our test on the 27th and 28th of April, we are going to be given either drop-down boxes or drag and drops. So we need to follow what we're given. And again, it's a triangle, PAL, is congruent to triangle, YAL. Again, the nice thing is we only had two options here for that. And the reason is we've got a side with 3 tick marks, we've got the blue angle, and then we've got the side with the 1 tick mark. So it looks like it's going to be side, angle, side. And once we prove that the angle, or that the triangles are congruent, then what we can say is that the parts of the triangle are also congruent, which is our CPCTC.